Hey guys, Liam here. Welcome back to the channel. So today I'm going to be solving another challenge. And yeah, if you enjoyed this content, please subscribe, like, leave a comment, and share with someone that might enjoy as well. And yeah, help me out with that, please. So today I'm going to continue the daily challenge, the daily challenge series. Uh, Today I will be solving this one, contiguous array. So let's get started then. Um, so given a binary array of nums, return the maximum length of a contiguous subarray with an equal number of 0 and 1. So for each 0 we need to have 1, right? So input nums, for example, 0, 1, output 2. Explanation 0 and 1 is the longest contiguous subarray with an equal number of 0 and 1. Interesting. Now 0, 1, 0 is 2, right? Because 0, 1 or 1, 0. Explanation 0, 1 or 1, 0 is the longest contiguous subarray with an equal number of 0 and 1. And for this one, is this, right? Explanation is the longest continuous subarray with an equal number of 0 and 1. Okay. One thing that it's good to mention. Okay, let's read the constraints first. So the length is around 1, so we don't have an empty array, and 10 powered by 5, right? And nouns y is either 0 or 1. Okay, so it's basically that, 0 or 1. All right. So one thing that is worth to mention is that the only way to have the same number of 0 and 1 in one place is to have the size of the subarray should be should not be odd, right? Should be even, right? So for example, here it's 2, so it's even, and here it's uh, 3, but the solution it's 2, right? So it's also even. And here 3 and 3, so it's also even. And the only way to have the same number of 0 and 1 is that the sum of it should be half of the length, right? So for example, we have 6 here, the length, the size of it is 6, and the sum should be 3, because we should have uh, zeros in the same place, right? But yeah, but the only thing that um, might be painful is that we cannot trust on the sum, right? Because I mean, for this case here, we can have like um, I don't know. For this case, for example, we can have like that, but instead of this, we might actually have this, for example. And when we sum up this 6, it will be 3, but it's not sequential, right? But it should be sequential. Given a binary array within the maximum of a continuous subarray with a equal number of 0 and 1. It doesn't have to be sequential, right? So for example, we have 3, we have 4. Okay, so what if we have like um copy this again? What if we have like this? We have 3, 3, 0, 1. This would be the maximum array because here we have 4, 1 and 4 zeros, right? Yeah, the description here is not very clear with that, but array with an equal number of zeros. Yeah, but I think we might consider that these would be valuable. This would be value, right? Valid. Sorry. Okay, so if this is valid, then we can consider that if the size is even and the sum is the half of it, then we can consider like a subarray with the equal number of 0 and 1, right? So it's this, in this case, this is a prefix sum challenge again, like we did yesterday. So in this case, we need to create the sum array that would be integer of this, and then we can iterate nums. So guard left last will be summary dot last, else if there's no last we continue, but firstly we just append none here, right? Um, okay, after that we append none plus last, right? So here we have return. Yeah, let's call the how can we call the solution, the result? Let's call output or result, maybe it's zero. And we return the result. Okay, so then here we need to print the summary, right? Sum array, and let's run. Let's see what we can get from here. So the sum array is 0, 1. All right. For this case, sum array it would be 0, 1, 1. Okay. And for this case, it's 0, 1, 2, 3, 4, 5, 5, 5, 5, 5. All right. Uh, so now we have the sum. Uh, so then we need to check, let's call it right equals to nums dot count. In the last exercise, we did a check for the num if it was equal to k, right? Because the main goal was to find the k, but in this case it's not necessary because for the previous challenge we might consider just one like a subarray of one item, but here the minimum is two, right? Because we need 0 and 1. So so yeah, and the nums can be one. So if we have one, we might just return 0, right? So we can just put a guard here. Nums dot count should be upper than 1. Otherwise, just return result. So yeah, we have the right here. We have the right. Okay, so right until right, it's upper than 0, right? We do it like that. So for left in 0 until right, we do it like that. So we start with this and the rest. Then we just go to this and the rest, go to this and the rest, go to this and the rest. So for this case, we don't need to check all the cases, right? Because we are starting from the right. I mean, yeah, we might need to check, right? Because maybe here we cannot find anything, but here we can find like this, right? Or here we can find like this, and here we can find like this because it's another. Yeah, but if we find here, we need to find here, right? Because this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we find here, we should find the next here at least because it needs to be even the length. Okay, okay, that's fair. So okay, so for example, from 1 to 9, it's 8, right? So from okay, so guard um, guard let's call it like that. Let size it's equal to right minus left, and if size it's an odd number, it's different than 0, or it's equal to 0, right? But it's different, then we don't even have to get it. Otherwise, if It is even, but um, yeah, here we can return zero right here, right? Here we can return zero. So if it is, what we can do here, and we don't need the result variable. So if it is even, what we can do here, we can basically check for the sum, right? So the left sum would be okay. That the sum would be left it's equal to zero. Then we can just get the nums or the sum array of right. Otherwise, we just get the sum array of right minus sum array left minus one, right? And then uh, we can get if sum divided by two it's equal or even sum it's equal to size divided by two, we have the answer. Then we return size. Yeah, I think that's it, right, guys? Um, let's check this out. Let's run it. Okay. Oh, yeah, I forgot the same. Yeah, I forgot the same thing that I did in the last challenge. So let's do it again. Run. Okay. What? What? Mm, let's remove this squared. Oh, I forgot the shortcut of Opera browser. Let's not consider this squared. I'm not. I don't really know if it's okay or not. Um, right. I mean, that's fine, right? Because if it is one, yeah, that's right. Fine. The issue it's not here. The issue it's right there. So okay, so first off, let's print here. Left, left, right, Right. Then we can print size, size. Then we can print or even size is even. And then we can print like the sum here. And we can print like return size. And here we can write failed return 0. And here it may actually return this. Okay, let's see. So the size is 1. Okay. Okay, so the size is not G's, right? Is right minus left plus 1, right? This is the size, the correct size. Okay, now it's working as expected. So let's comment this print and see how it goes. So let's comment this one, comment this one, because I mean this print right here, it's good for debugging in lead code, but it's not good when we are running because it takes time. So for the time consideration, it might fail just because of it. So let's submit and see how it goes. Okay, wrong answer here. Um, yeah, we might actually pass 467. That's good. Let's add this test case right here and check again the. Oh, I forgot about the shortcut. So command. This doesn't work. I have to do it by my own. Just deleting this. All right. Let's run. Let's see. So the size is 8. Okay. Size is even. The sum. Okay, so here should already return, right? What is this? Sum. Oh, I didn't print it this time. Okay, let's do it again. Okay, for this case, the size is even. Okay, so first case would be here, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, right? 8. So the size is even, and we have 3, 5, 1, and 3 zeros. Okay, that makes sense a lot. If we have one of these 0, then we would have 4 ones and 4 0. Okay. All right. So size 7. Yeah, we just jump in. Size 6 is even. But what are the answer? The answer should be this, right? 3. The answer is 4. What about it? Ah, okay. The answer is here. Okay. Okay. Yeah. So we cannot do like that. Okay. So then we need to find the maximum size, right? So var size or max size that is equal to 0. And then size would be, our maximum size would be the max around maximum size and the size itself. And then we return the maximum size. I think this would be the answer. Yeah. All right. So then we just comment this, comment this, comment this one as well, this one as well, this one. Okay, let's submit again. Okay, okay. So the time limit exceed. Interesting. Interesting. Because right here we have a squared. So returning the maximum size just in the beginning. Mhm. Let me think. I can actually. Mhm. Let me redo this thing. Let's use this as a test case. So I can actually think on another approach for this. So maybe I start from the zero. Let's see. For left in zero until the nums dot count minus two in this case, right? So then we can start from the beginning. So then, or maybe I can even try to check for the summary right here, right? Because I mean, we might actually have like the answer right here. Mm, I mean, it's not wrong to do it like that, but yeah, this is not a good approach. I would have to check. Yeah, guys, I don't know about this one. I think I might actually have to leave it like that for a while. Let me just get back without using maximum size and try to study a new approach. Yeah, yeah, sorry about this one, guys. But yeah, this is a humble and honest solution from my part. And if you see some ways to improve this, please share here in the comments. I would love to receive this feedback. So thank you guys for watching and for uh, yeah for joining for this journey. So thank you.